Bismillahirrahmanirrahim. My dear students, I am Muhammad Abdul Saeed, your mathematics teacher. Yesterday we were having our exercise 1.2 and there were different types of matrices we discussed. We solved the question of exercise 1.2. Last time we finished our question number 5, exercise 1.2, that was the transpose of matrix. What is meant by transpose of matrix? Yesterday I told you, if a matrix is given, then you can find the transpose by interchanging rows into columns. By interchanging rows into columns, you can find the transpose of any given matrix. Today we will discuss about the addition and subtraction of matrices, scalar multiplication of matrix. Rather, you can say a matrix is multiplied by a real number. After that, inshallah, we will talk about additive identity and additive inverses of matrices. This is your lecture number 7, chapter number 1. We are going to start now, question number 6. Verify that if A is equal to 1, 2, 0, 1, then you have to prove that A transpose, whole transpose is equal to A. Basically, it is just like double complementation law, like A complement, whole complement is equal to A. This is just like minus into minus, that is plus. The same idea. Now A is equal to 1, 2, 0, 1. Taking transpose on both sides, interchange rows into columns. First row will become first column, that is 1 and 2. Similarly, second row becomes second column, 0, 1. So this is your transpose. Again, taking transpose on both sides, 1, 0, 2, 1, transpose. Implies that A transpose, whole transpose is equal to, apply the transpose here, again first row becomes first column, 1, 0, and second row becomes second column, 2 and 1. You can see what you got. You got A, which is equal to A. So in this way, hence A transpose, whole transpose is equal to A, this is proved. Simply in this part you have to take 2 time transpose. First transpose, change rows into column. Second time transpose, you again change rows into columns, and that will become your original matrix A. Like that, minus minus plus, A complement, whole complement is equal to A. And similarly, A transpose, whole transpose is equal to A. Hopefully, you can find the second part. You can prove second part exactly on the same lines. Just I solved first part in front of you. After that, before we start our next exercise, we have addition and subtraction of matrices. Dear students, in case of addition and subtraction of matrices, there is only one and only one condition, that the matrices must have same order. I'm repeating, for addition and subtraction, the matrices must have same order. Then you can easily add or subtract by adding corresponding elements. Then you will find the answer. For example, if A is equal to 1, 2 and 3 and B is equal to 5, 7 and 9. You know that these A and B are conformable for addition and subtraction. In case of addition, you will write down A, 1, 2, 3, then plus value of B, 5, 7 and 9. Now students, you will add corresponding entries, first plus first, second plus second, and third plus third. So in this way, you will find your answer 6, 9 and 12. So this is your answer. This is the way how you will find addition of matrices. In case of subtraction of matrices, for example, we are taking the same example, but here we can change the sign. This is minus. Same method, same technique, you simply change the sign in the center. First minus first, second minus second, and third minus third. Here you will get minus 4, minus 5 and minus 6. That's your answer. So I hope that, dear students, you got the idea how to add and subtract the matrices. After that, scalar multiplication. Scalar multiplication means you have to multiply any matrix by positive or negative real number. For example, if you have A is equal to 1, 5, 2, 3, and you want to multiply this matrix by a constant number, by a scalar number, by a real number, that may be plus 2. Suppose you want to find 2A. 2A means 2 into A. 1, 5, 2 and 3. What you will do? Each element, each entry will be multiplied by 2. 2 1 2. Similarly, 2 into 5, 2 into 2, 2 into 3. So you will have 2, 10, 4 and 6. This is the scalar multiplication or multiplication of matrix with any number. If it is minus 2, okay, multiply each entry by minus 2. If it is written minus 1 over 2, so it means that every member, every entry will be multiplied with minus 1 over 2. That is known as multiplication of matrix. I hope that you got the idea. After that, we have additive identity. First of all, dear students, I want to tell you what is meant by additive identity. First, we will talk about additive identity of real number. Then we will come to the matrix concept. Additive identity means the number which is added to any number and there there will be no change in that number, you will get the number again. I am repeating, additive identity is a number which when added to any number and there is no change in the value of that number, and you will get the number again. For example, you have 5 plus 0 is equal to 5. You got the same number. 3 plus 0 is equal to 3. You are getting same number. Similarly, minus 10 plus 0 is equal to minus 10. And generalize this rule as a plus 0 is equal to a. B plus 0 equal to b, c plus 0 is equal to c. So which is the number which is giving you the same number as it is, that is 0. Every time this is 0. So in case of real number, additive identity is 0. And dear students, convert this idea to the matrix concept that additive identity is 0 here, but in case of matrices, additive identity will be null matrix. And what is null matrix? Null matrix is denoted by O, which is 0, 0, 0, or this is 0, or O is equal to 0, 0, 0, 0. You can see null matrix or 0 matrix is always the identity of matrices. Additive identity of matrices. So from this concept, we shift our idea from real number to complex concept. After that, we have additive inverse. What is meant by additive inverses? Here we have additive inverses. Listen carefully. Again, I am defining the additive inverse in real numbers. The two numbers are additive inverses of each other if by adding you get additive identity, means 0. Again, I am repeating, the two numbers are additive inverses if after addition you are getting additive identity. That is additive identity, means additive, that is 0. For example, you have 3 and minus 3, that will be 0. This is additive identity. After adding, you are getting additive identity. It means they are additive inverses of each other. 3 is the additive inverse of minus 3, and minus 3 is the additive inverse of plus 3. Similarly, you can have minus 1 over 5. And here will be plus 1 over 5, that is 0. Again, you are getting 0 by adding two numbers. So these two numbers are additive inverses of each other. Now convert this concept into complex numbers, or you can say rather into the matrices. Convert this idea to the matrices. Now I am defining the two matrices when they are added to get 0 matrix or null matrix. Again I am repeating, the two matrices which when added to give null matrix or 0 matrix, then they will be additive inverses of each other. For example, you are having 1, 2, minus 5 and 7. If you take the negative of this matrix If you take the negative of the matrix, in the previous lesson I have told you what is meant by negative of matrix. Simply you change the sign. Simply you change the sign, and at that time I told you additive of negative of a matrix means additive inverse. I told you that was A, another was minus A. You simply change the sign to that. For example, what is the additive inverse of this one? What is the negative of the matrix? It will be minus 1, minus 2, plus 5 and minus 7. Now you add them. First plus first, 1 plus minus minus 1, then 2 plus minus minus 2, and minus 5 and plus 5. Here is 7 and minus 7. You cancel them and you will get 0, 0, 0 and 0. This is null matrix. If you check from here, the additive inverses are the numbers which are added to get 0, and the additive inverses of complex matrices, additive inverses of matrices are the two matrices which when added to get 0 are null matrix. That is known as, they are known as additive inverses of the matrices. What you will do here in case of additive inverse, if A is given, simply you will find minus A, and then you add them to get, that will be null matrix. So they are known as additive inverses of each other. Dear students, I hope that you got these concepts. Now we are able to start our exercise 1.3. Exercise 1.3. Which of the following matrices are conformable for addition? You can check from the book. Which are conformable for addition? Here is A, 2, 1, minus 1 and 3. B is 3 and 1. C is 1, 0, 2 minus 1 and 1 minus 2. D is 2 plus 1 and 3. E is minus 1, 0 and 1 and 2. And F is 3, 2, 1 plus 1 and minus 4, 3 plus 2 and 2 plus 1. Dear students, these are the matrices which are given to you, and we have to check which matrices can be added. Here I told you about the addition and subtraction of matrices, that they must have same order. Mean number of rows and number of columns must be same. Here is 2 rows, 2 columns. Check another one which is having 2 rows and 2 columns, this one. So A and E can be added. Because they have same order. Similarly, B, this is 2 rows and 1 column. This is having 2 rows and 1 column, and you can check Along with that, B, and this one is, don't be worried, this 2 plus 1 is 3 in fact. First you add them, and subtract them, and then check what is the order. So here is B and D can be added. After that, C. Check 3 rows, 2 columns. These are 3 rows, R1, R2, R3, and 2 columns, C1 and C2. So 3 rows and 2 columns. Check another one. Yes, F. First you add them, 1 plus 1 will be 2, this will be 5, this will be 3, and after that check their order. So F and C are conformable for addition. C and F can be added. So dear students, this was your question number 1. I hope that you understood that. Because already I have discussed before the start of exercise, so this will help you to understand the different questions, how to solve them. After that, find the additive inverse of the matrices. Question number 2. Find additive inverse of matrices. Remember that I told you, in case of additive inverse, you simply change the sign. In case of additive inverse, you simply change the sign of all entries. For example, here is given matrix additive inverse. Okay, A is 2, 4, minus 2 and 1. What will be the additive inverse? I told you additive inverse is actually negative of the matrix. So additive inverse is minus A. You multiply both sides by minus. 2, 4, minus 2 and 1. Here, multiply negative sign, or rather you can say minus 1 to all terms. All entries. Minus 2, minus 4, minus minus plus, and plus minus minus. So this is additive inverse of A. Similarly, you will have B is equal to 1, 0, minus 1, 2 minus 1, 3, and 3 minus 2 and 1. Additive inverse of B is minus B. So minus sign is multiplied to all entries of the matrix. Here is minus, multiply minus with both sides. You will have 1, 0 and minus 1, 2 minus 1, 3, and 3 minus 2 and 1. Implies that you can get multiply with negative sign all entries, change the sign. Minus 1, 0 plus 1. You can write down plus 1, if you don't write, no problem, that is same. Minus 2, 1, minus 3, minus 3, 2 and minus 1. Dear students, this was the idea how to find the additive inverse of a matrix. Similarly, we can find F part. I hope that the other parts you can do by yourself. here in F, 3 under root 1 minus 1 and 2 under root. Additive inverse of F is minus F, 3 under root 1 minus 1 and 2 under root. Multiply with negative sign, but remember this minus sign will not go inside the square root sign. You will write down minus 3 under root like this. Here is minus 1, minus minus plus 1, and then minus 2 under root. That is the additive inverse of your product. After that, we have question number 3 relating to scalar multiplication. So in case of scalar multiplication, you will multiply the matrix with the given digit, with the given number, and you will do as given in the part. Question number 3. If A is equal to minus 1, 2 and 2 and 1, B is 1 and minus 1, C is 1 minus 1 and 2, and B is 1, 2, 3 and minus 1, 0, 2. We have this question number 3. We have these matrices. Then we have to find, for example, part number 1. We have to find A plus 1, 1, 1 and 1. Remember that you will apply the value of A here, from here. Minus 1, 2, 2 and 1. Plus 1, 1, 1 and 1. Now simply you add, just like question number 1, or rather question number 2. First plus first, and second plus second, third plus third, and fourth plus fourth. Corresponding entries will be added or subtracted as given in the question. This is 0, 3, 3 and 2. One important rule is that whenever you add or subtract the matrices, there will be no change in the order of the matrix. You will get 2 by 2 matrix if you have the matrices of 2 by 2 order. Then you, after adding, you will get that answer. After that, for example, part number 4 is, you can do other parts in the same way. Or rather, you can check part number C, that is easy. C plus minus 2, 1 and 3. Okay, apply the value of C here. 1, minus 1 and 2, plus minus 2, 1 and 3. You will add the matrices, same rule, same order, first plus first, second plus second, and third plus third. You can see here is 1 minus 2. Plus minus minus 1 minus 2 will be equal to minus 1, and here is 0 and here is 5. So you have 0 and 5. That is your answer. Again, you can see that our matrices were having the order, same order. What was the order? 1, answer, it also has the same order, 1 by 3. 1 row and 3 columns. After that, we can solve 2a. I have taken this example in fact. So we can write down another one. Here we can see, we can have the part number 6. Part number 6 says -1 into b. -1, and what was b? b is 1 minus 1. So each entry will be multiplied by -1. Here is -1 into 1. -1 into -1 implies that 1 -1, and here will be minus plus and 1. That is your answer. You simply change the sign and that is your answer. After that, I hope that you can do other parts by yourself, by taking help from here. Dear students, if you have any problem, any confusion, then you can ask on your WhatsApp group. You can clear it. Rather in the Zoom section, you can ask the question. Actually, we have limited time in the Zoom section, so that's why it is better to have the WhatsApp group. It will have the comprehensive result, inshallah, and we can spare more time to check and more time to discuss the questions. After that, question number 4. It is the extension of your question number 3, in fact. Perform the operation and simplify. Perform given operation and simplify. Here we have part number 1 and 2. They are similar. So you can have part number 1, 1001, then plus 0, 2, 3 and 0, and plus 1, 1, 0, 0. 1, 1, 1, 0, sorry. Dear students, very easy question again. This is the continuation of question number 3. Here we will solve first these brackets. What we will get? The answer, definitely it will have the same order of the matrix. Then it will be added to outside that one. First you solve these brackets. How? First plus first, same rule. 1 plus 0, second plus second, third plus third, and fourth plus fourth. This is 1, 1, 1, 0. Here is 1 plus 0, 1. This is 2. This is 3 and 1. Then again we have 1, 1, 1 and 0. Similarly, you can have first plus first, second plus second, third plus third, and fourth plus fourth. This will be 2, 3, 4, and 1. So dear student, that is your answer. Is the addition. In the same way, you can find the answer. Or we can do other parts. Part number 4 and 5 are similar. So I can solve part number 3. It's easy, but the order is different. So I'm solving so that you may not be confused. Part number 3. Here is 2, 3 and 1 plus 1, 0, 2, 1, 0 and 2 minus 2, 2 and 2 and bracket closed. Just like the previous question, we will solve these brackets first. These brackets. You simplify and then add that. 2, 3, 1. Then first minus first. Second minus second. Third minus third. That will be 2, 3 and 1. Here is minus 1, minus 2 and 0. Again we apply the same method. First plus minus minus. I am writing directly. I hope that you can understand that one. Plus minus minus. 2 minus 1. Similarly, plus minus minus 3 minus 2. And third plus third, 1 plus 0. And your answer will be 1, 1 and 1. This is your answer. I hope that you understand this question. First step is to solve the brackets, find the answers, and then add with the same method. Part number 4, 5 are similar. They are a little bit bigger matrices. Their order is 3 by 3. So we can solve one part from here. And sixth part is just like part number 1 we did already. Part number 5. 1, 2, 3. 3, 2, 1. 3, 1, 2. Here is 1, 0, minus 2. Minus 2, minus 1 and 0. 0, 2, minus 1. 0, 2, minus 1. Okay, dear students, you have the matrices of order 3 by 3, don't worry. Same technique, same method. First plus first. 1 plus 1, second plus second, corresponding members will be added and subtracted. 3 plus minus minus 2. Here is 3. Fourth minus 4 plus minus 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 2. That is 2 minus 1 and 1 plus 0. Then again 3 plus 0. 1 plus 2 and 2 plus minus minus 2 minus 1 implies that you will have 2, 2 and 1, 1, 1 and 1, then 3, 3 and 1. This is your answer. So question number 4, other parts you can do. Now we can start with question number 5. And rather, question number 5 is a little bit lengthy. So, dear students, I want to give you this assignment here. This is for Sunday, 19th of April. assignment number 7. You will listen the lecture very carefully, and after that write down your assignment on your separate paper and solve it, and then send it to me on the WhatsApp. It will be better. So that's why I am writing down this assignment on the whiteboard. Okay? Do as directed. Number 1 is order of matrices must be same for dash of matrices. Option is A is addition, B option is subtraction, C is multiplication, D is options A and B. Options A and B. Number 2 is every diagonal matrix is not a scalar and or identity. Every diagonal matrix is not a scalar or identity matrix. This is true or false. Simply here you will write down true or false. Every diagonal matrix is not a scalar and identity matrix. True and false. You simply write down true or false. This is the nature of question, okay? After that, point number 3, if A is equal to 2, 3, minus 4 and 5, verify that A transpose whole transpose is equal to A. Number 4, if A is equal to 2 minus 5, 7, then find minus 3A. Then find minus 3A. So dear students, this is your assignment number 7, and you will write down on the separate page, solve it and share with me in the WhatsApp group. Before leaving, today we discussed about the transpose of the matrix, addition and subtraction, scalar multiplication, additive identity and additive inverse. Inshallah, in the next lesson, remaining portion, we will discuss about the remaining portion, and inshallah we will do it. Try best and try your best other parts which I have left for you. Solve them, and if you have any problem, any confusion, don't worry, I am here to answer you inshallah. Okay, thank you very much. Allah Hafiz.